This is a Google Forms survey, and we need to import the data in Excel, then code it. Then we start doing the descriptive and inferential statistics using Excel or SPSS. To do this, we go to link sheets or link to sheets, click there, and here it will just tell you to create new spreadsheet. So I will just create one. After that, I need to go to File and then download Microsoft Excel. So once I have it downloaded here, I could just put it in my, let's say, desktop, or just open it. So here it is. First step is data cleaning. So we need to clean the data. So we have semester. So some students are put in different semesters here. So I could just put this, for example, graduated. Okay, so I will just put graduated for those who have anything that is above a bachelor degree. This one could be omitted. So this is data cleaning. So PhD researcher could say just graduated here. So again, completed university studies. So I will just put graduated. Okay, master students as well. So graduated in relation to the bachelor degree. That's it. So once we clean this data, I think this is what should be cleaned. The second step is data coding. So what we need to do is that we need to replace these labels with numbers for us to process them using the statistical measures. So I will just select everything here. Okay. And then I will go back to the questionnaire. Usually I need to have a code book. So let's take this as a code book. Let's say the set of questions here as a code book. So you go to the questions. So here female, male. So I could just code female as 1 and male as 2. So I will just click Control H to find this find and replace function. So female, and I would just click match case for match entire cell contents if I want to be sure. So 1, and I replace everything. So just so because I didn't select it here, so I will just replace everything. And then I will do the same for male. So I will replace it with 2, replace all. And then the next question is about the semester. So 2, 3, 4. So I will just take this, replace it with 1. So semester 2 is coded as 1. It's the lowest value. Then the second semester, which is 4. So it's going to be coded as 2. And replace all. Then the sixth semester is going to be coded as 3. And then graduated is going to be coded as 4. So graduated is going to be coded as 4. And replace all. That's it. So here, no one. So we could just see we can delete this one because it's not clear. This one 4, 4. This is again 4. So M1 means the first year in a master program. Now we clean this. We could do the same for and coded this. We could do the same for the generation. So we have different generations. We have generation Z, born in this age period. So I could just see what I can do. So I could start with the let's say generation X. Then I move to the other generations. But mostly I assume that most of the respondents are belonging to generation Z. and millennials. So before that we have baby boomers and silent generation. So we have silent generation, then baby boomers, then etc. So I could just start with the silent generation and I will just code them as 1. So silent generation will be coded as 1, replace all. Okay, so match case. So it doesn't exist in the dataset, so you won't find people who are silent generation, but still, we code it as 1. Then the second one is 2. So it's going to be coded as 2 and replace all. The same, so those people do not exist here in this sample. So let's see generation X. And then code it as 3, replace all. So we have 8 cases or 8 replacements. So the same for the others. Millennials, they are going to be coded as 5 or 4, right? Or 5. Where did we stop? So we have 1, 2, 3, 4. So 4. And replace all. Then generation Z is going to be coded as 5. Generation Z is going to be coded as 5 and then replace all. So this is the code book. Then for these Likert scale statements, it's going to be straightforward. So we're just going to go back to the survey. So here strongly disagree is going to be coded as 1. So strongly disagree is going to be coded as 1. And then I will replace all. Then disagree is going to be coded as 2. And then replace all. Then I will code the other one, which is neutral, as 3. And replace all. Then I will code the agree as as 4. Replace all. And strongly agree as 5. So strongly agree as 5 and replace all. So here I have strongly 4. So let me just put strongly 4 and replace all because I just miscoded it. Then we have a few times, never, etc. So this is another scale. So I will check this one. So here we have never. So this is another scale that I need to code. Never is going to be again coded as 1. And then replace all. Then I have the second one, which is few times per year. So it is going to be replaced as 2. Then I have the next one, which is once a month. It is going to be replaced by 3. Replace all. Then we have a few times per month. Then it's going to be replaced by 4. Replace all. Then once a week. Then this is going to be replaced by 5. And then we have few times per week and every day. Few times per week, it is 6. And the last one is every day. which is 7. So this is like 7-point Likert scale survey. So here, replace all. That's it. So once I have the data coded like this, what I could do further is that I could just remove this, how often do you encounter each of these. So I will just replace it with nothing, like, and replace all. That's it. Okay, in relation to your studies, to what extent do you agree with each statement? This one also should be replaced with like nothing, so to speak, just to make it empty. And replace all. Then save. So once I save this, the next step is that I need to, let's say, so I will just take it here, call it coded survey. And then what I need to do is that I need to import it to SPSS. So I just right click and then open with, and I choose IBM SPSS statistics. So here I will just click OK. And here are the questions and variables. So I could just remove these symbols. See if that could be removed. Yeah, so if it is not removed, I can just take it to Excel and I will remove it on Excel and get it back here. So let me just open Excel to help me bit with data cleaning. So I could just put these statements here and Control H. So I will take this one, this symbol, I will replace it with nothing and replace all. And the same for this symbol, that is going to be replaced with nothing again. That's it. So, and I will just copy these. It's better that I give them codes like burnout. So if I include here burnout 1, so academic burnout 1, like this, academic burnout 2, etc., etc. So I will just take this. And this is academic burnout 2. And then I will just drag and drop. I may just need to remove the dots because okay, 1, 2. So I need 3, etc. 3, 4. Okay, didn't capture this. So 4, 5, etc. 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I will just copy these and paste them to SPSS to see whether they are good to go. So Control V. So here, if a variable name contains an illegal character, it's the dot. So I need to remove that dot. So this dot needs to be removed. So replace all. Now I think it will work. So here we go. So this is for academic burnout. I could just do it like this. This is L1. Okay. I have some codes here like I1, I2, I3, E1, E2, E3, etc. These are like sub-dimensions of academic burnout. So I will just copy this and paste it here. And the same for the other one. Needs to be pasted here. And if we go back to the questionnaire to see the names given to these scales. So here I don't have the names anyways, but I can just find them in the survey because these surveys were adopted from these two studies. Here, this one and this one. So they are supposed to be already valid and reliable. So this is called burnout and engagement in university students. So here it talks about burnout. And here they use this Maslach burnout inventory for students, including exhaustion, cynicism, and reduced efficacy. So I think these are the sub-dimensions of the scale. So if you see here, I, E, and then A. So that could be it. Reduced efficacy. All right. Or depersonalization, etc. So anyways, let's just go back to our data. And we're going to run first descriptive statistics of, let's say, demographic variables. So this is like generation. Could just shorten this so that it will appear nicely on the table. So you'll just go to Analyze, Tables, then Custom Tables. Then I will put gender, then semester, then generation here. And then row labels in columns. Height, okay. So I could have this table. So semester, then generation, etc. But here I didn't code these numbers, so that's why they are not showing as labels. I need to go back here, and for gender, so we coded 1 as female and 2 as male. So that's what we did. And then for semester, we have this code. So 2 is going to be coded as 1, or semester 2. So 1 is going to be assigned to the second semester. 2 is going to be assigned to, or rather, yeah, to the fourth semester. And 3 is going to be assigned to the sixth semester. And 4 is going to be assigned to graduated. Graduated. And click OK. Then we have generation. So we need to do the same for generation. So I need to come back here. And for this generation, I need to give it a code. So this is like generation. So 1 is going to be ascribed to this generation, silent generation. Then 2 are going to be assigned to the other generation, which is baby boomers. Then 3 is going to be assigned to the next generation, which is generation X. And then 4 is going to be assigned to the other generation, which is millennials. Okay, millennials. So I guess most people are either millennials or generation Z. Okay, and this is like the age of each generation and the birth date. Then we have generation Z. So this is going to be 5. Generation Z. Okay. Now that I have them here, I could just rerun the custom tables. And yeah, the category labels cannot be positioned because 2 or more categories have the same confusing value labels. Which one? So we have female and male. We have semester. We have silent generation and others. So let me just go to custom tables, reset, and then I put back gender, semester, and generation here, and click OK. And here they are. So I need to add frequencies there, and percentages. So you go to percentages, put them here, and apply. Click OK. Let's see. So this one does not work. It shows all of them 100%. So instead of choosing, let's say, row percentage, I need to choose column percentage, this one. Here I could also customize the label as F meaning frequency, and this symbol meaning percentage, and apply to selection, close, OK. And this is the table that I need to have. So I just go to Microsoft Office Word and put it there. So this is like for the results. The first section of the result is the sociodemographic variables. So you could just auto-fit it and put table 1, demographic variables. Okay. I could add a graph for this, so I would just select these and I could visualize this to see it in a better way. So let me just visualize it. So again, select this, insert, recommended charts, and I could choose this one. Okay. Then insert data labels, then put it here, and I could just drag this to the end, and here are the generations, semesters, and genders, so to speak. So I could just put it here. I could further edit this figure even here, like I could just change the color to make it APA style. So to make it APA style, I need to make it gray. This one. So this is now in APA style. I could just remove these lines, but it's okay. So here I need to say that for the demographics, I need to say this is like figure 1, demographics. So figure 1, demographic variables. And so this is the result. I could just put it like this. And then references and insert table of contents. And in the page number, I could just insert page number on the top right to make it APA style. All right. So female, male, then we have semesters along with the frequencies. So most people are males and they are studying in 6th semester and they belong to millennials and generation Z. Few people belong to generation X. So you could see this curve, but mostly belong to generation Z, born between 1997 and 2012, ages between 10 to 25. And then we have this generation Y. All right, that's good. So now we can proceed with the academic burnout scales. Academic burnout. So all right, so this is for the demographic variables. I need to put it like this. So that's what I keep just updating this table of contents automatically, like you see. So results, demographic variables, academic burnout, along with page numbers, etc. So I need to go back to the survey, and here I need to again code this. So remember, I need to give them labels. So here strongly disagree is going to be assigned to 1. So this is strongly disagree. So 1, strongly disagree. 2 is going to be disagree. 3, neutral, etc. So I'm just copying them just to avoid any spelling issues, so as not to repeat this. So anyways, neutral. Then we have 4, which is agree. And then 5, which is strongly agree. So 5 is strongly agree. All right. So I need to click OK. And that's it. Once I have them like that, strongly disagree, disagree, neutral, strongly agree, I will just copy this and I will keep clicking Control V to paste it here. In case I have many, I will just select everything like that and I will just put them back here for the sake of productivity. So anyways, I have just coded all of them. The same for this. This is a different scale. So it uses, instead of agreement, it uses frequencies. So if I go here, you will find never, few times, per year. So I need to put these values. So for 1, I will say never. For 2, I will say what? Few times per year. Then for 3, it's going to be coded as once a month. And for 4, it's going to be coded what? Yeah, a few times per month. And then for 5, yeah, so for 5, it's going to be coded as once a week. What is it? So yeah, once a week. And for the 6th category, yeah, it's going to be coded few times per week. And then for the 7th category, it's going to be coded as what? So let me just see. Yeah, every day. Okay. So here I need to do the same. So I will just copy these. Again, select everything and keep doing it like that multiple times. Sometimes some items may need to be reverse coded, so I need to be careful with that. So once I have them like this, I could run exploratory factor analysis to determine the factor structure of this scale. Since I have a sample size that is 100 and above, you can see here, if I click here, you could see the code. These are the codes and the labels I was doing on Excel and SPSS. So to do exploratory factor analysis, let me just save this. I need to go to Analyze. Okay, where is it? So Analyze, then I need to go to dimension reduction, which is this one, then factor. I need to put all of these variables here. So just select everything, put them here. And the descriptives, I could just choose chemo, that is Kaiser-Meyer Olkin test, and part test of sphericity, determinants, etc. For the extraction, I could choose maximum likelihood, and I could choose display as script plot. And for the rotation, I could just choose Varimax rotation with continue, or I could also choose Promax. So I just did stick to Promax rotation. For the options, I could just so I don't have missing values, but if I have them, I could replace them with mean. And coefficient display format, I will sort it by size and suppress small coefficients. And I need to put this value that is below zero point 0.3, which is 30%. So I need just anything that is uh, below 30% not to appear on the table. So click OK. And here is the Kaiser-Meyer-Orkin test of sampling adequacy. It shows that there is this 79% of sampling adequacy, which is good. And the sig value, which is the p-value, it is statistically significant. It is below 0.001. So anything that is below 0.05 is statistically significant. If it is above 0.05, it is not statistically significant. What do we mean by statistical significance? We cannot generalize the results from this sample of 100 people to the whole population, let's say, of all students who are enrolled in the university. Okay, then we have commonalities. So commonalities here, we could just check all of these commonalities and see which items to remove. So I will just need to remove items that have a commonality that is below point sometimes 4 5. So here I could just remove this one. I have no choice, otherwise I will not be able to have comfortable livelihood in the future. So this item can be removed. So it does not load good in terms of the scale, so because it has this value of 44%. This one also, to avoid problems with my parents or scholarships if I don't study. So this one can be removed, so it doesn't relate, and you could see from its wording also it seems strange. Once I have good reasons for going to university, however, now I wonder whether I should continue. So this one could be also removed. And this one again, I can effectively solve the problems that arise in my studies. This self-efficacy. So I could remove 4 items to make this scale, let's say, more valid. Here the factors that I have 6 factors that explains 75 of the variance, and these are displayed on the scree plot. And if I see them here, I could see how they load. For example, item 5, 6, 3, 4, 2, 1 load into one factor, which is good. Then item 2, 3, 1, 4, 2, 3 again, 1, 5, 4 load into the second factor, which is good. I have, yeah, so just tell this one like 2, 3, 1, and then we can also say 4, they load into the second factor. But again, this 2, 3, 1, 5, and 4, they load into the fourth factor. So here, this is the fourth factor. So SPSS does not know what the title that it can give to these grouping of items. So it's up to us to read them, understand their content, and give them, let's say, a title. Like we could just read this, and I could call this, for example, academic burnout, or let's say academic self-efficacy, or academic interest, or something like that, etc., etc. In general, I see that this scale has good factor structure. So what I need to report in my data analysis, so I just need this, the commonalities. And by the way, for the commonalities, I need to delete some items, but I need to describe the process. I need to say how I managed to delete these items. I need to see the first test I did, and based on the first test I did, these are some values that I used to delete items. I need to state that to show how I made the transition, like when I was improving the reliability. So I need to put these, so I could just go to survey, and I will add appendix A, let's say EFA, exploratory factor analysis, and I put it 1, meaning like initial exploratory factor analysis. Then I will just put it as heading 1. Then I will need to put these items or these results here. Okay, so here I could just fix this by going to layout, auto-fit content, auto-fit window. So factor analysis is used to validate the scale. But you know what? We already have these scales validated. Why? Because we took them from other studies. But still we need to run exploratory factor analysis to see whether like what this study found in this year, which is 2000 and let me see, 2002, because that was all the year. So a lot of things changed from 2002 till now. That's why I need to check the validity, because also here they say they did what we call factor loadings. You see factor loadings, they are talking about factor loadings of MBA or MBI, sorry, and then we're not irrelevant, so, or we're not invariant across all samples. So they also use this expected three-factor structures using confirmatory factor analysis. To use confirmatory factor analysis, I don't need only SPSS, I need also AMS, but that's a bit complex to do. So let's just stick to SPSS for now. So here we have this 1, 2, 3, 4. So this one we could just call it what? So item 1, 2, 3. Emotionally drained. So this is like emotional draining. So if we go here to this scale, so it's called exhaustion. So I will just call it exhaustion, okay? So exhaustion 1, exhaustion 2, exhaustion 3. Then this is exhaustion 2. Then exhaustion 3. So here I feel emotionally drained, etc. Studying or attending class is really straining. I feel burnt out from my studies. Again, it's exhaustion 3. Then this is exhaustion 4. Then we have exhaustion 5. Okay, so these are the items that fall into what we call emotional exhaustion. Then I have become less interested in my studies. I have become less enthusiastic. I have become more cynical. So this is cynicism. Cynical, you see. So I took it from this study. It's called cynicism. So I will just again, because cynicism is not only, I cannot ask you just one question to see whether you are having this emotional exhaustion. I should ask you multiple questions, and based on all of those questions, I will give you a score, like out of 10, out of 5 here. And if it is high, I will assume that you are emotionally exhausted. If I found, for example, 4 or 5, this means that it is high, that you strongly agree with items, therefore you are emotionally exhausted. And it is used as a test in psychology, you see. So anyways, so we have cynicism 1, then we have cynicism 2, then we have cynicism 3, then okay, we have cynicism 4. Okay. Then I can effectively solve problems. I believe that I can make an effective contribution. In my opinion, I'm a good student. So let me see which one. So it's called reduced efficacy. Reduced efficacy. So reduced efficacy. So I need to put it without space here, or to put it like this. Reduced efficacy. Okay, reduced efficacy. Want to test the reduced efficacy of English department students. So this is reduced efficacy 1, reduced efficacy 2, reduced efficacy 3, reduced efficacy 4, reduced efficacy 5, reduced efficacy 6. So there are 6 items that are used to measure reduced efficacy. And this one, so it's not academic burnout. So this is motivation rather. So, and motivation is divided into I, which means intrinsic, and E is, which means extrinsic, you see. So I1, I2, I3, this means intrinsic motivation, which is internal motivation, like you do something because you love it. And then you have the second one, which is extrinsic motivation. So let me just label those accordingly. So I will just put intrinsic motivation as I am 1. Then we have I am 2, and then I am 3. This is intrinsic motivation. Okay, so I need to stop here, I think. Where is it? 3. Then we have starting from 4. I need to put, for example, I am 1. This is not I am, so it's EM, which means external motivation. So external motivation 2, external motivation 3, external motivation Internal motivation 4, external motivation 5, and then external motivation number 6. Let's see whether it makes sense. Okay, now there is another one. So it's called, I think, task motivation or something. Let me just see the study, the original study. It's published here. So here, ordering motivation and Likert scale ratings. So here, this study used different types of motivation. We will see which motivation they are talking about. So they said external motivation and e-motivation. They call it e-motivation. So this is what it means. So e-motivation. So let me just put it here. So EM1, EM2, etc. AM3, etc. Okay, nice. So this is internal motivation, external motivation, e-motivation, exhaustion, cynicism, reduced efficacy, etc. So these are all the scales that we have here. I need to test the reliability of these scales or subscales. So I need to go to Analyze, then Scale, then Reliability Analysis. Then I will just display variable names here. And I would put, for example, IM 1, 2, 3. And I will just label it as IM, which means internal motivation. Okay, so here for the model I will just include alpha, not omega, not split half, not Gottman, not parallel, not strict parallel. So I will keep it to alpha. And here for statistics I need to choose scale if item deleted, click continue and click OK. And this is the reliability of the first dimension. So I could just take this one and put it in appendix as well. So here I could just go to home, view, navigation pane, go to appendix, and I will put appendix, let's say appendix 2. Appendix 2. Then I will just highlight it this way. Then I will put IN, which means internal motivation. Then I will do the same for external motivation. Okay. So external motivation. So I will just go to recently used dialog box, reliability analysis, and then I will just put these back and just choose external motivation, put it here, and put the label here, and click again OK. And this is external motivation. You see it has this 721, which is good. So it's 72.1%. So anything that is 0.7 and above, it's good in terms of the reliability. So here I put external motivation and just put it this way. Then I will do the same for the other one, which is e-motivation. So recently used dialog box, e-motivation, put it here. And I will put it like this as a title, click OK. And this is the Cronbach alpha of the items, copy it and put it here. So EM, meaning e-motivation, will need to be included here. That's it. So this is as far as motivation is concerned. We could just check with the other one, with the other scale and subscales. Like you need to check for exhaustion, cynicism, and reduced efficacy. So again, reliability analysis, I need to do the same for exhaustion. So you see reliability, you do it multiple times, depending on the Likert scales that you have on your questionnaire. So we call it exhaustion. So E, click OK, and that's it. So here I just put this as E, meaning exhaustion. And then that's it. So this is for exhaustion. I need to do it. So all of the scales are reliable. So all the scales are reliable, which is good. So we stopped at the E exhaustion. We can do the same for the other one. So cynicism. So just put C and then OK. So this one and this one, copy, paste, which is C, standing for cynicism. And then for reduced efficacy, I will do the same for reduced efficacy. But remember the items that we should delete from the to enhance the factor structure. So this one is good. So here, even though we included all items, still the reliability is good. So we call it reduced efficacy. So RE, and then I will put it here. So if I want to go back to the exploratory factor analysis, I need to see which items I need to remove. For example, I could just remove this one. I have no choice. This one was like badly loaded into the scale. So I could just start with removing this one. So this one falls within E1, which means external motivation 1. And another one, I think that's it. Let's just remove this. And still, if I don't want to remove it, it's okay. Still, the reliability was good. So it may not be removed, but this is an option to remove it to improve this, because people may have other choices, not only to study. Okay, so this is in brief how we test the validity and reliability. The next step, we move to hypothesis testing. But before moving to that, I need to reduce the items together. Like, for example, external motivation 1. So I could remove it and I retest the reliability to see whether it still makes sense without external motivation 1. So I will just keep 2. Call it R means revise, click OK. No, so the reliability dropped. So if it dropped, I should not remove it. So I should just keep it. So I don't need to remove it. So yeah, so I will just keep external motivation 1. Although it was not loading that good, but still we can accept that threshold. There are some studies that support that. Anyway, so let me just go to transform and compute variable. And I will just start computing or reducing the variables. So I will start with IM, which means internal motivation. Here I need to put this equation, which is mean, and then open parenthesis, and then I put IM1, comma, IM2, comma, and then IM3. So these ones, like IM1, IM2, IM3, and then I just close the parenthesis and click OK. And what will happen is that a new variable will be created at the end. It's called IM, which stands for internal motivation. So I just reduced those items into one scale after testing their validity and reliability, of course, because we cannot do that if we don't test the reliability and validity. That's why we tested the reliability, to see whether we can group them together or not in the first place. So then we use the recently used dialog box. So again, I need to choose the mean. So instead of IM, I will just include EM. So here, what I could do another step. Like I could just take this one, double click, and it will move directly there. And then put a comma, double click, it will move, comma, double click, it will move. That's it. So again, I will just go to compute variable, and then I will do the same for E motivation. So E motivation. So here I need to do what? So I need to double click this and it will move there. Then put a comma, then double click this, it will move there, comma, double click this, it will move there, and click OK. Then recently used dialog box, and then exhaustion, so I will just call it E, meaning exhaustion, and then I will do the same, exhaustion 1, comma, exhaustion 2, again, comma, exhaustion 3, comma, exhaustion 4, comma, exhaustion 5, that's it, and then click OK. Then we'll have cynicism, so it's going to be C, and I need to remove these here, and I go to cynicism 1, comma, cynicism 2, comma, cynicism 3, cynicism 4. Okay, then the last one is reduced efficacy, so RA or RE, yes. So I will just remove these. Again, I will just go to reduced efficacy 1, reduced efficacy 2, okay, reduced efficacy 3, reduced efficacy 4, reduced efficacy 5, reduced efficacy 6. Click close the parentheses and click OK. That's it. So what will happen is that we have these scales here grouped together here. So this one is going to be internal motivation. Yeah, so internal motivation, which is IM. The second one is going to be external motivation, which is EM. So this is going to be external motivation, which is going to be called EM. The third one is going to be what? E-motivation, which is going to be called A. The third one, or this one in this scale, is exhaustion. Exhaustion, I think it's written like this. E, exhaustion. Yeah. Then we have cynicism. Cynicism. So it's coded as C, labeled as C. This one I need to label it here. Then we have reduced efficacy. Reduced efficacy. Reduced efficacy. So reduced efficacy, RA. So here I could just put a symbol like this. Anyways, so once I have these grouped, I could run regression, correlation, etc., and descriptive statistics. So I could just run descriptive statistics like mean, median, mode to see the general tendency. So I just go to analyze, then descriptive stats, then I could just choose frequencies, and I will move all of these variables here, create EPA style table, display frequency tables, remove. So I just can choose the mean, median, the standard deviation, the minimum, the maximum, the skewness and kurtosis in case I want to check the normality of the data. Click continue and click OK. So here they are. So based on the mean, you see here it's 4. This one is high. So most students have high internal motivation compared to external motivation, and low e-motivation. And they have, in terms of exhaustion, they have reduced efficacy. So it's more, yeah. So this is what students suffer from here, this department. That's interesting. So here I just could, so instead of saying academic burnout, I could just say motivation and academic burnout. So this is what students suffer from. They suffer from reduced efficacy. So here, reduced efficacy, it's typed like this, I guess. Okay, without, yeah, reduced efficacy. So this is table 2, descriptive stats. So table 2, descriptive stats of descriptive statistics of motivation and academic burnout. So people believe that they can't do tasks. I could visualize this, like I could just take this table copy it here, go here, put it here. And let me just see the missing values. There are some missing values. I need just to check them out. I will just include the mean and this one. So I will just copy it again, and I can reverse paste it like this. So why? Because I need to create a graph. So I will just create a graph. I will just highlight this. Sometimes Excel is like can be defaulting. So I will just click recommended charts. But it's unfair to compare Likert scales that are on 5 with the ones that are on 7. So that will not show good results. So what I need to do is that I need to compare motivation alone and exhaustion and the other one alone. So I need to create two graphs. So I will just create the first graph, recommended charts for the first graph, and I put it like this. We'll call it motivation, and like data labels for motivation. And I do the same for the other one, which is academic burnout. All right, so for academic burnout, you could see here internal motivation is the predominant one. This is why the graphs visualize this. And this is a 5-point Likert scale, like put it as a note from strongly disagree to strongly agree. For the other one, let me just see what to put. So insert recommended charts, and I will put it like this, and you will see the difference. So reduced efficacy is the highest. You can visualize it like that because this is a 7-point Likert scale. So it's unfair to put them together because like this is like a 5-point Likert scale, and this is 7 points. So that's why I separated them. Like motivation and 5-point Likert scale, academic burnout. So I could just say this is figure 2, motivation, 5-point Likert scale. And then I could say figure 3, academic burnout, 5-point Likert scale. Okay. Oh, it's not 5 points, it's 7 points, okay, which is academic burnout. I was expecting that I will find people suffering from reduced efficacy. People think that they cannot complete tasks. So this is a problem, big problem that we have. Not exhaustion, not cynicism. Exhaustion, moderately, they are exhausted, but not that much. They are comfortable. Internal motivation, they are internally motivated. At least those who completed the survey. Remember, because we are using what we call voluntary sampling. So those who are interested are the ones completing the survey. So may have a sample that is not representative of all English department students. So this result should be interpreted in this light. Okay, so what I can do, I could also run correlation and and regression. So I could just run correlation. So I go to analyze, but before that I could test, let's say, if there are outliers. So to do that I need to go to analyze, then I could go to descriptive stats, then explore. All right, yeah, so because this data does not belong only to English department students. But I could just from the semester filter those, like I don't know. Let me just run the other tests. Let me run correlation. So I will just go to analyze. Then, but before that, I was checking the outliers. So I go to explore, and then I will put all of these variables here, and I will see if there are some outliers. So outliers mean extreme values that would skew the results. So I will just click OK. And then let me see the outliers. So this one, so for example, this one has many outliers. Like for internal motivation, it has this outlier which is 87, 62, 72, 28, 73. So 87, so how can I detect this? So I just go here and I go to 87. For example, this one, 87, this one. This female fourth semester or fifth or sixth semester student was just saying strongly disagree, strongly disagree, strongly disagree, strongly disagree, strongly disagree. never, never, few times. She is not with us, like she is another word. So I could just take her out, like I could remove it. I just could remove this student from this because maybe she was not paying attention. She was just completing the questionnaire just to satisfy you. Like maybe this is one exception. You could see that her data is different from the others. Like it does not follow normal distribution compared to other respondents. So I could just take this one. So it's 87, right? Let me see if I found it in
Yeah.
other places. I will take her out. So 87. Let me see the other one. For
There is some
external
difficulty in
motivation,
translation to
no. No, she changed her mind for the others, like e-motivation, exhaustion. This one, no. Yeah, reduced efficacy. So she changed her mind, like she was just not paying attention in the first skill, internal motivation, maybe. She's not internally motivated, like. Okay, but let me see other extreme cases. We have 87, we have 62 and 72. So 62 and 72. 62, 62, this one. Again, strongly disagree, strongly disagree, disagree, disagree. You see, extreme values. They are not with us, like they are in another world. Like they don't follow a normal distribution. You see, that's why species marks them as being suspicious.
there
So
is
talk to him because there is another version of species. It's called PSPP. You can install it for free, and I can share with you the video to practice. It's called PSPP. There is another software that is available for free that is called Jamovie. Yeah, Jamovie, and there is another one that is called JASP. So JASP, Jamovie, PSPP. These are the three, let's say, software that are free. So Jamovie, JASP, and PSPP. So PSPP is like SPSS. It's free version of SPSS. You could just install it without any problems. And you can run descriptive statistics like this, and you combine it with Excel if you have Excel, and you start running these charts and putting them together. But before that, you test the reliability to see if those factors that you grouped would be good or not. Anyways, I need to share the video with you. That's how you can practice because you cannot remember all of these things. Let me just proceed with this. This study is really interesting, except that you included the diverse sample. So for me here, I'm not going to be, let's say, I could do what we call transformation. So I will just calculate the z-scores and I will not remove anyone from the data. So what I can do is that I can just go to analyze descriptive stats. I will just go to descriptives and I will put these constructs here and I will just save standardized values as variables. Click OK. So here what happens is that at the end of the survey, we have those variables like these ones, like it's we have the mean and we have plus minus the mean. So it's like we're putting standard deviations here. So we have the mean score, and anything that is below or let's say above the mean is measured here. And this is like a way to cater for what we call outliers. So I can just use this data and I run, let's say, yeah, I can run a correlation. So I go to analyze, then correlate, then bivariate correlation, and I will put these z-scores here. And I could also choose Spearman for more safety. So I expect that they are correlated. So I will choose one tail in terms of the direction and click OK. So here is the table of correlation. You see that most of them are correlated, like external motivation is negatively correlated with the internal motivation and e-motivation and exhaustion. It seems that they are negatively correlated for internal motivation. For the other ones, they are positively correlated. You see here the symbol plus or minus, minus when you don't have plus, and you have these three symbols meaning statistical significance. So I will just copy this, put it here, and say correlation. Okay. And then I will put this table here. And then layout, autofit table, autofit window. And we could run other tests if we want, like I don't know, we could just run other tests. For example, here, since they don't show like this, I will just put them as 1, 2, 3, 4, so that they can be, let's say, correctly formatted. So 3, 4, 5, 6. And I need to know what these numbers stand for. So I need to put it, let's say, below or something like that. I will send you this to format it further. What I can do, I can run other tests like regression, etc. I can run test comparison, which is independent samples t-test to compare males and females. So I will go to gender. We have 1 and 2, male and females, and I put these here, put them here, click OK. And you can see that there is a statistically significant difference in terms of cynicism between males and females, in addition to exhaustion. Who will be exhausted more? So let me see in cynicism. So we have the mean score of females. They are more, I think, suffering from this cynicism. And yeah, and the exhaustion. Again, females. So females suffer more from exhaustion and cynicism compared to males. Males are comfortable in their life, relatively speaking. Put here t-test, t-test, and I will just highlight it this way, and I will put it like this. I can also run ANOVA, so I will just go to Analyze, Compare Means, and then I will put one-way ANOVA, and I will put the factor, which is the semester, and then I will put these z-scores here. And in the descriptives, I will just choose descriptive stats and means plots, in addition to, let's say, post hoc, which I can choose less significance difference in case there are some significant differences later. But let's just stick to this. And here are the descriptive stats, and here are the statistical significance. There is no statistically significant difference in terms of the semester. And you could see, although here it keeps fluctuating between the 4th and 5th or 6th semester, still, there is no statistically significance or statistical significance. So let's ignore the semester. Generation, let us compare generation. So instead of the semester, we can compare generation, and we see. We don't need to report everything. We report just the statistically significant differences in case here. Like this one for generation, we have exhaustion and cynicism. So which generation shows exhaustion, cynicism, and reduced efficacy? So let's see which generation. So here, let's see the mean, if it is high. For example, generation X, born between 1965 and 1980. Again, those who are born in this age. So the older you are, the more you are exhausted, the more you are showing cynicism, the more you have this reduced efficacy. Let's see them visually. You can see them visually to see. You see here, it keeps increasing. It keeps increasing. Let me see. So generation X, millennials, Generation Z. So you see, Generation Z, born between 1997, but this was not statistically significant. Let me see the ones that were statistically significant. This one. So reduced efficacy. So Generation X was showing high values in reduced efficacy. Cynicism, Generation Z, showing cynicism. And exhaustion, again, Generation Z. So Generation X, in fact, showed that a higher value only in terms of reduced efficacy. Like, there is a quote about this. So what I need to do is I need to report these values that are statistically significant. So I need to put this in the study, like, and the others, I will just ignore them. So I will just put these values here, and I will just take the table. Which table? So I will need to take the ANOVA, the descriptive stats, the ANOVA, and that's it. So in addition to effect size and post hoc tests. So here correlation, then I will put here ANOVA. ANOVA. So I will just click layout, auto fit content, auto fit window. You see, I need to just adjust these tables here. That's it.